Hi guys, in this video we're going to be looking at high-resolution mass spectrometry and then we'll summarise.
So we saw in last year's course how mass spectrometry works and that it tells us the relative molecular mass of a compound and also gives us fragmentation patterns. So we know the masses of individual pieces of the compound, which then gives us information about the structure. The problem is that more than one compound can have the same mass-to-charge ratio. In this example, we have butane, and this has 4 carbons, each of which have a mass per mole of 12 grams, and then it has 10 hydrogens, each of which has an atomic mass of 1 gram per mole. So if we add this up, 4 lots of 12 is 48, and then we add the 10 from the hydrogen. This gives us a total molar mass of 58 grams per mole. We can compare this to propanol, which has 3 carbons, all of which have an atomic weight of 12 grams per mole. It only has 6 hydrogens at 1 gram per mole, but it also has an oxygen at 16 grams per mole. So if we add this all together, 3 12s are 36, another 6 is 42, and then 16 also gives us 58 grams per mole total. Now these are very different molecules, but just by chance they have the same molecular mass to 2 significant figures. So if we only know the MR of these compounds to 2 significant figures, then we couldn't tell them apart. So that's a limit of low-resolution mass spectrometry. There is, however, high-resolution mass spectrometry that we often abbreviate to HRMS, and this gives the MR values accurate to 4 or more decimal places. So if we now compare butane and propanol, we can see that to 4 decimal places, they do in fact have different masses, and so we can tell these apart. This doesn't solve the problem that we can't tell the difference between isomers, because these have an identical MR. If they contain all of the same atoms, like here we have propanol and propanone, there's no way to tell these apart based just on mass. You would have to use something like NMR. Sometimes, if you're given a particular compound, you need to be able to work out the accurate molecular mass from the masses of all of the atoms it contains. So you could be given data like below. We learnt last year that carbon-12 is defined as having an atomic mass of 12.000, and everything else is measured relative to this.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the Snap Revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.